Hey, Picamsters, this is Mrs. Vandelay bringing you another blank wall of section or chapter 15, section 6, part 4, hopefully the last. So as we finish up, excuse me, what happens if we have a mixture of weak acids? Okay, what do we need to do? Well, if one of them has a really high value of Ka, that will be the focus. For example, if we have a strong acid and a weak acid, focus on the strong. So if we have hydrochloric acid, this will be formic acid, and then water. Well, what's going to happen here? Here we have HCl, as you know, is a strong acid, single arrow, K is infinity. Okay, here we have formic acid, 10 to the negative 4. Then we have water, Ka or Kw is 1 times 10 to the negative 14th. Okay, so which one should we focus on? Well, formic acid is pretty strong, 10 to the negative 4, but not when you compare it to hydrochloric, which is infinity, all right? So you would concentrate on the HCl. Okay, so what's the effect of adding a strong acid to the weak acid? The strong acid will produce the greatest amount of the hydrogen ion concentration, so it'll have the greatest effect on pH, okay? Well, let's continue this problem, assuming that everything has a 0.1 molar to determine. So I'm like, all right, determine the equilibrium concentrations of all these things, okay? So I put in all 3 things, okay? And so I found out from HCl what my H plus concentration is, 0.1. I looked over water too, what the heck, you know, I'm at it. I used 1 times 10 to the negative 7. And then what? Here is my work for my formic acid. And here's my Ka is equal to 1.8 times 10 to the negative 4. X squared is 1.8 times 10 to the negative 5. The hydrogen ion concentration is 4.2 times 10 to the negative 3. All right, so what will be my equilibrium concentration of each of these? So my H3O plus, well, what am I going to do? I'm going to add them up, all right? So I contribute this. So what's 0.100 plus 0.0042 plus, well, 1 times 10 to the negative 7, all right? So my conclusion is what? All right, so that is my H plus concentration. What did I do? I added all of these up to find the H plus, all right? So what's going to be the greatest contributor to the H plus concentration? Obviously, the strong acid is. Because formic acid had a pretty high Ka, it within 3 sig figs would also contribute as well. Not a whole lot. Obviously, the strong acid HCl is going to contribute more, but even your formic acid, the 3rd sig fig, if you will, came from the formic acid. What about your water? The acid from your water? No. With 3 sig figs, it is long gone, isn't it? We should probably go ahead and answer the rest of the question. All right. What's the equilibrium concentration of the formic acid? Well, what's 0.100 minus X is 0.0958. So I just took this number minus my X value. Let me scroll down a little bit more. Here we go. So 0.1 minus this value right here will give me this value. Okay, right here. H3O plus concentration, that's when I added them all together, and so there we have that. And then the formate ion is what our X was right here, and so it is 0.0042. So I think I've answered all the questions on this problem. Let's go to the next page. So the last example was a strong acid and the weak acid, and hopefully the math showed you that pretty much your strong acid will dominate, and the majority of the H plus concentration will come from the strong acid. But what if we have a mixture of 2 weak acids, all right? If we have a mixed 2 weak acids, then there are 3 potential sources of H plus, each acid, and of course, you know, maybe your water too. So it says calculate the solution that contains 1 molar of HF and 1 molar of, this looks like phenol, okay? This is actually going to be an alcohol group. And look at that, it's a really, really low Ka, doesn't it? So go ahead and why don't you set up the ice tables for both of those, solve for the H plus concentration for both of those, and see what you get. So pause this, work on it, and when you're done, come back. All right, so here are my two different ice tables. Hopefully you've noticed that here's your X from your hydrofluoric acid. Here is your X from your phenol. And notice that this is much bigger than that. They're both weak acids, don't get me wrong, but notice that they're much different. This is a much higher number than this one. I should probably go ahead and figure out if this is a 5% rule or not. And actually, this is going to be a 2.7%, so I'm okay because the 1.00 was big enough. Even though this is a -4, it still was going to work out okay. Okay, so just letting you know, I hadn't forgotten about that 5% rule. So what is my total H plus? I add them all together. All right, and if I were to take the pH of that. If you want to go ahead and try this, what is the negative log of 0.027013? And then what is the negative log of 0.027? You're going to see if I have 2 sig figs, it's the same answer, isn't it? So that, again, which weak acid is stronger will be the one to predominate. Now, I didn't include water in this, all right? I could have, but it would be 1 times 10 to the -7th, which is even smaller than this number. So if this didn't count, water certainly would not count, okay? But let's go ahead and see the next problem. Well, guess what? There isn't another problem. There's another whole nother section. So we are done. I told you this would be the ending of part 4. Anyway, so I was thinking of an example. If we have, let's say, the Ka of something is like 10 to the negative 10th, and then you have water, which one will predominate? But I think that's coming up on a future one. So just hang on to that thought and don't wait to be great. We'll see you next time. Bye-bye.